I'm going to split this up into two separate equations. The oxidation portion and the reduction portion. And then we know that the iodine is the oxidation because it goes from being negative to 0, so it gets less negative. So we know the electrons will be on the right side. But first, we need to balance the atoms. So we have a coefficient of 2, so we can have 2 iodines on each side, and then charge on the left is 2 negative, or minus 2. On the right side it's 0, so to balance that we add 2 electrons to the right side. On the next part we actually have to add H2O because there is oxygens on the left side, which we were able to skip on the first part because there were no oxygens. And then we have to balance the elements, of course, so add 2 chromium, so there's 2 on each side, and then we put a 7 in front of the H2O because there is 7 oxygens on the left side. And then we have to add 14 H plus ions to the left side in order to balance the 14 H's, or the hydrogens, on the right side. Okay, so now we can balance the electrons, and since this is reduction, they go on the left side. And then to know how much we need to know our oxidation numbers. So charge of chromium collectively is 12 plus, and on this side it's 6 plus. Okay, so we have to add 6 electrons. And if you didn't catch that, that's because oxygen has an oxidation number of 2 minus, and there's 14 minus. So that must mean that chromium must be 12 plus, since there's 2. Okay, and then we have to multiply this entire thing by 3 in order to get our electrons on the left to match our electrons on the right, because electrons lost must equal electrons gained. So once we've done that, we can cancel our electrons and bring everything down in our completed balanced redox reaction. Okay, and then everything is aqueous except for H2O and iodine because it's a liquid and it is a solid. And we are done. Alright, this one should go by a little bit faster since we know the methodology in order to accomplish this. So we know that Mn2 plus is our oxidation portion because it goes from being 2 plus to 7 plus. So we need to add 5 electrons. And then once more, this is all oxidation numbers, so 2 oxygen, 8 minus, this must be 7 plus in order to achieve the charge of negative. Okay, and then we need to add H2Os because yeah, there's oxygens on the other side, and then we do have to add hydrogen on this side because of that. Alright, and then the second portion, we have to do the exact same thing. So this is the reduction part of it. We need to add H2Os on this side, 3 of them, and we need to add 6 H pluses. All for the same reasons as in the last part of the video. Alright, and now we need to balance the electrons. So it goes from being 5 plus to 2 plus. So we need to add 3 electrons. Okay, so now that we have all this balanced, we still need to get the electrons to cancel. So the electrons on the right side must equal that of the left side. So multiply everything up here by 3, multiply everything down there by 5, and then we just distribute and we have everything. Alright. Oops. Sorry, I'm not that interesting. Yeah. It is what it is. Alright, so now we can start canceling things. So first cancel our electrons, and then since we have like terms on each side of the equation, we can cancel all of these H2Os, and then leave 3 over here, and then do the same thing with the hydrogen ions. So there was 24 over here, 30 over here. We can cancel those and get our 6. And then now that we canceled everything that we can move our remaining pieces down here. And just like that, you balance your redox reaction. And then of course, all of these are aqueous, so I'm going to save the time and not write down all of them, but they are aqueous, so yeah. Thank you.